37 on section 4.4. First thing you should notice is that it's quadratic in form, right? So since it's quadratic in form, it might possibly factor. If you cannot see that it's quadratic in form, do a substitution. If you can figure these out without doing a substitution, I recommend you do so. But if you need to do a substitution to get the hang of it first, then do that. So I'm going to let some other letter like u, some other variable, equal sine of theta. That way I can put just u in for sine theta and put u in here for sine squared, only it'll be u squared. So that will give me 9u squared plus 12u plus 4 equals 0. So then this gives me a problem to factor. It looks to me like this actually might be a perfect square trinomial because 9 is a perfect square and 4 is a perfect square. Square root of 9 is 3, square root of 4 is 2, 3 times 2 is 6, and 12 is twice of 6. So I'm pretty sure this is a perfect square trinomial. Did you notice that? So it would be 3u plus 2 squared. Right? Let's double check it. 3 times 3 is 9, u squared. 2 times 2 is 4. And then 2 times 3 is 6, plus 2 times 3 is another 6 for a total of 12. It's a perfect square trinomial. So let's put our sign back in where the u is. That means we would have 3 sine theta plus 2 squared equals 0. Well, how can we get rid of a square? Square root both sides. Square root of 0 is just 0. So 3 sine theta plus 2 equals 0. Then we would subtract the 2, divide the 3. So sine theta would equal negative 2 over 3. Is that a ratio from our chart? No, so we must use a calculator. So not on chart, use calculator. The instructions say to find the angle from 0 to 360. So we start by doing the inverse sine of negative 2/3. What do we get? Make sure your calculator's in degrees. Isn't it a negative? So when you plug this in your calculator, you should get a negative 41.8 degrees. But we want our answers to be from 0 to 360. What's wrong with that? It's not from 0 to 360. It's less than 0. But we still have to keep it in the same quadrants. So where is sine negative? So we need answers in these two quadrants, but they need to actually be the answers from 0 to 360, not a negative 41.8. So how do we take that answer and change it? So this is kind of our reference angle is 41.8. How do we change that to a quadrant 3 angle? For quadrant 3, we're going to take 180 and add our reference angle 41.8. So what's the quadrant 3 angle going to be? Yep. And then for quadrant 4, we actually take 360 and subtract our reference angle 41.8. 3, sorry. Okay. So that should be the solutions for this problem. So section 4.4, Cody and Crystal, was a lot of problems are quadratic in form. If you need to do a substitution to figure out how to factor that quadratic, good, that's fine. If you don't need to use a substitution, you might get better at it as you go along without having to use a substitution. But basically this thing here, 3 sine theta plus 2 quantity squared, is this thing factored. But I kind of used a u substitution in here to help me figure it out. Okay, so then when you get to that point, you just solve it like you would have in section 4.2 or 4.3. Once you get it into factored and out of its quadratic in form. Sometimes you have more than one factor and you take each factor and set it equal to 0. But in this case, our two factors are identical. So taking each one separately and setting them equal to 0 wouldn't have made any difference because we would have gotten the same answer from each one. So, yeah, you only list the answers once.
So if there were two different answers, then you would do the same thing, you would find the answer.
If there were two completely different factors, then you would take this factor, set it equal to 0, and solve it. Take this factor, set it equal to 0, and solve it. Just like we solved this one. And since it's not on the chart, if it's on the chart, you just work backwards on the chart. But if it's not on the chart, you have to use a calculator. And make sure you follow the instructions. This one asked for degrees between 0 to 360, so we use degrees. If it doesn't ask, usually you do radians. Okay, does that kind of show you a little bit? Because this was one of the more straightforward problems from section 4.4, because it's definitely a quadratic and solvable. We also did, when we did problem 30 earlier, not 30, but 15, I think. Where was it? When we did problem 15 earlier, it was a similar situation. It's just that we couldn't solve the quadratic in form until we had changed the cosine to a sine so that we had it all in terms of sine. So we changed the cosine squared into a sine squared. Then we were able to put it all together into one quadratic. We figured out that it wasn't factorable, so we used quadratic formula to solve it. So it's still a problem that's quadratic in form. We just had to do an extra little step with an identity to get it into that quadratic form first before we did the quadratic formula, right? Same sort of idea. Only this time it was two different answers. And wait, now I'm concerned. I only found the answers that quadratic formula gave me. Oh, I didn't finish this problem, did I? Did you guys realize that? I was kind of being confused, sorry.
Yeah, you said.
Okay. So, this actually gives us sine x, doesn't it? Sine x equals 1 plus or minus square root of 7 over 6. Well, that's definitely not on the chart. So you're definitely going to want to use your calculator. Is 15 in radians or degrees? It's in radians. Okay, so this time you want to use your calculator in radians. Sorry, I didn't finish problem 15. Use your calculator in radians to find your answer. So you're going to do the inverse sine of 1 plus square root of 7 divided by 6. And that'll give you an answer. And then you want to do the inverse sine of 1 minus square root of 7 divided by 6. Anyone helping me find those so that I'll have them faster? It's in radians, though. Okay, so I have inverse sine of 1 plus square root of 7. And I need an extra set of parentheses or I'm going to mess this up. Divided by 6. So, did you guys get the same answer? Okay. And then I'm just going to do the same thing but with a minus instead. So negative 0.278. Okay. But sine is positive, and this is a first quadrant answer, but sine is also positive in second quadrant. So what do I need to do with this? So this is quadrant 1, because that's what my calculator would give me when it's positive. So I need to change, so that's one of the answers in quadrant 1, but I also need quadrant 2. How do I use that as a reference angle in quadrant 2? Except that it's not 180, it's pi. So 3.14159, so 2, minus 0.653. What'd you guys get for that? Okay, the bell's gonna ring. I need to get the review out to you. So that's 2.489. Okay, now this one's trickier because this is quadrant 4, but it's not in the right interval for quadrant 4. So we have to do 2 pi minus 0.278 for quadrant 4. And then there's quadrant 3 where we're going to do pi plus 0.278 to find that answer. So you end up with 4 answers. Is this looking better? Those of you that checked it in the back, problem 15. Someone should have spoken up earlier and said I hadn't finished it. So 3.14159 times 2 minus 0.278 gives us 6.005 on that one. And then we do 3.142 plus 0.278 is 3.420 if we're doing the same number of decimals. So that should be like your 4 answers, I think. You all got the review. Thank you, Mr. Ash, to start on. But we have another review day. Aren't we so glad we have another review day?